video tutorial series of the operating system. I am your instructor Varshata. Let's start our lecture series. So today's topic, that is process control block, context switching and thread. So today we are going to cover this topic in this lecture. So first of all, let's start with the process control block. Before starting the process control block, in last lecture we have discussed about what is process and what is program. Okay, so now all of you are aware about the what is process and what is program. Program is what? Program is a set of instructions that is stored in a disk storage. But when this program is under executions, at that time it will be stored in, loaded in the memory. So when this program is under the execution, so at that time we can say it is the process. Okay, so when this program is under the executions, we require many informations for execution of this program. For example, where program will be loaded in the memory for the execution, what is the address of the starting of that particular memory block where this process is stored, what is the end address of this particular memory block, what is the counter, okay, which peripheral device it needs. So each and every information should be maintained. So where we can maintain, where we can store this type of such type of information, so we can store such type of information in PCB, that is process control block. So in process control block we store the entire information about the process. Okay, so that information we will see in next upcoming slide where when we will see the structure of the PCB. Okay, so PCB, that is what? A process control block is a data structure maintained by the operating system for every process. Whenever any process is created, PCB is created for that in the operating system in the kernel space. Okay, PCB is used for storing the collection of the information about the process. So as I told you, it will store the any information, process status, process identification, process memory area, process counter, all the informations will be stored in the PCB. The PCB is identified by an integer process ID, that is known as PID. We can say the process identification number, that is the integer number that is used to identify the process uniquely in the operating system. A PCB keeps all the information that is needed to keep the track of the process. Track of the process, that means whether the process is blocked, whether the process is in the execution state. There are numbers of state for the processes that we have seen in the last lecture: ready state, running state, block state, exit state. So now in which state the process is that, so that informations will be stored in the PCB. So PCB will keep track of each and every state of the processes. Now the next point about the PCB is what? The PCB is maintained for a process throughout its lifetime and it is deleted once the process terminates. So existence of PCB till the process is under the execution. When the process will terminate, PCB also will destroy. Got it? The architecture of PCB is completely depend on the operating system. It may be possible that PCB in the Windows operating system is different. PCB in Linux is different. PCB in Solaris is different. Okay, so architecture structure of the PCB, that depends on the operating system only. Okay, PCB lies in the kernel memory space because it contains all the information about the process that is under the execution. So that is in the memory space. So now let's start with what is PCB. Here you can see this figure represents the process control block. The basic introduction about the PCB. So first of all, the process ID, that is process identification number. So unique identification for each of the process in the operating system, that is defined by the process ID. That is the first information stored in the PCB. Now next is process states. So Process state, that means the current state of the process. For example, whether the process is in the ready state, whether it is in running state, or whether it is in waiting state. So these are the different state for the processes as we have discussed in the last lecture. So whether the process in which state, that information will be defined by the process state field. Then next is pointer. So pointer is what? A pointer to parent process. That means a pointer, if this process is a child process, then it will have the information about the parent process. So pointer is about the parent process, so that information will be stored in the PCB. Then next is priority of the process. So that will be stored in the priority field. Whether the high priority process or whether it is the low priority process, so that information will be stored in the priority. Then next is the program counter. Program counter is a pointer to the address of the next instruction to be executed for this process. Okay, so whenever you have written the numbers of instruction in program, so one by one your instruction will be executed. So program counter will represent that particular instruction which is in the execution. So when the instructions will be executed one by one, the program counter will be increment by one by one. Okay, so that is what the program counter that is used for the pointing to particular instruction when it is in the execution. Now next field is the CPU register. So what the informations will be stored in the CPU register, so that you can see the various CPU registers where process need to be stored for the executions for the running state. For example, register A, register B, register C, etc. There are different types of registers are there for storing the process. So in which register process is stored, so that informations will be stored in the CPU register. And next is IO status information, that is input output status information. So this includes the list of the input output devices allocated to the process. Okay, so which input output devices is allocated to the process, that all the informations will be stored in the process control block. Then next is the accounting informations. So this includes the amount of the CPU time it is used for the process execution, time limits, etc. That means the process required how much time for the execution. For example, the one process is required the 10 milliseconds for the execution. So that 10 milliseconds will be stored in the this accounting information. When the process starts, how many times it's acquired the CPU, for example 3 milliseconds or 4 milliseconds. So that informations will be stored in this accounting information. So this all are the basic information that is stored in the process control block. It may be possible there are many more informations will be there in the process control block. So here this is the basic information that will be stored in the process control block when the process is created. Now next topic is about context switching. So what is context switching? That we have discussed in last lecture, if you remember. Okay, so context switching, that means what? Here just take the basic idea about the any switch that is in your home. For example, switch for fan or switch for light. So what you will do? You will on the fan or you will off the fan at the same time. Can you execute the same mode at the same time, on and off? No, it is not possible. At a time, fan can off only or fan can on only. Got it? So the same scenario is here in the terms of the context switching, in the terms of the process. Okay, so here you can see the process X and process Y. Got it? So process X is off, then process Y is on. If process X is on, then process Y is off. Same thing is that at a time only one process is there is in under the execution. Okay, so if process X is executing, process Y has to wait, and if process Y is executing, process X has to wait. Got it? So that is what the context switching. This also we have discussed when we have discussed about the kernel. Okay, at that time we have discussed about the user mode and kernel mode. So program can move from the kernel mode to process can move from the kernel mode to the user mode or user mode to the kernel mode. So when this moving is there, at that time it required the switching. Okay, so that switching is known as the context switching, and that is done by the system call. Got it? So here, what is context switching? Context switch occurs when the computer CPU switch from one process or thread to the different process or thread. Context switching allows for one CPU to handle the numerous process or threads without the need of the additional processors. We don't require the additional processor. Using the single processor, we can execute the numbers of processes, but it requires the context switching, because you have to switch every process one by one for the execution. A context switch is the mechanism to store and restore the state or context of the CPU in the process control block. Now all of you are aware about what is process control block. So context switch is a mechanism to store and restore the state of the information, state of the processes in the process control block, so that the process execution can be resumed from the same point at the later time. So when the process is blocked for some reasons, so now if the process is under the execution again, so from where process have to start, that information we will store in the process control block using this context switching. Any operating system that allows for the multitasking relies heavily on the use of the context switching. Okay, if the operating system defines the multitasking, that means at the same time multiple task is under the execution, that the context switching is more at that time. So to allow the different processes to run at the same time. So if multitasking is there, it allows the different processes to run at the same time when we have the context switching. So if the context switching is there, then we can execute multiple tasks at the same time. So in multitasking, it plays the major role for execution of the any process. Okay, now typically there are three situations where the context switching is necessary. Here it is shown. First is a multitasking. So as we have discussed in last slide, so when there is a multitasking, we require the context switching. Then kernel user switch. Okay, so that also we have discussed in the last lecture, when the program moves from the kernel mode to the user mode or user mode to the kernel mode. So at that time we require the context switching. And another is the interrupt. Interrupt, that means when the CPU is interrupted to return the data from disk read. That is, if any blocked operation is initiated, so at that time the process has to switch from running mode to the block mode. So that is what the interrupt. So these are the situations where we require the context switching. Now these are the steps that is used for executions of the context switching. So when the process is switched from one state to another state, what will happen? So first of all, save the context of the processor, including the program counter and the register. If process will go in the block state, so at that time we have to save that particular state, where the process is, what is the memory address, everything, where that information we have to store. So where we will store in the process control block. Now update the process control block of the process that is currently in the running state. So now the process is in the running state, so we have to store each and every information that in the process control block. So we should have to update the process control block every time when process is resumed and when process is blocked. Then next is move the process control block of this process to the appropriate queue. That means we have to move the entire process in appropriate queue. So for example, you are following any of the algorithm, whether it is a round robin, whether it is a shortest job first, etc. So based on the this algorithm, we have to move the process, whether it is in ready queue, whether it is in job queue. Okay. Now another step is what? Select the another process for the execution. So now we are selecting the another process for the execution. So what we have to do? Update the process control block of the process selected. Okay, that process is blocked till now. Now the process is under the execution. So again we have to change the process control block of the newly arrived process for the execution. This includes the changing of the state of this process to running. Now next is update the memory management data structure. This may be required, that is depending on the how address translation is managed. Because when the process is under the execution, address translation is there. Because when the program is compiled, the address is different. When the program is under the execution, its address is different. So at every time we require the address translation. So that address translation should be maintained in the process control block. Now last step is what? The restore the context. So that means restore the context of the processor to that which existed at the time and the selected process was last switched out of the running state by loading it in previous value of the program counter and other register. That means if now process is selected which was blocked because of newly arrived process. So which process is blocked, now it is in execution. So we have to restore each and every value where process blocked. Okay, so the steps will be followed when context switching is there. Now let's see in terms of figure. So here you can see whatever we have discussed that is defined in the figure. For example, process P0 is under the execution and P1 is the ideal. Okay, so if P0 is under the execution, so what will happen? Interrupt or system call is there. So it will save all the state of the process P0 into PCB0 and reload the state from the PCB1, that you can see. It will reload the state from the PCB1. Now PCB1 means process 1 is under the execution because of interrupt or system call is there. Okay, so now again what it will do, it will save the state into the PCB1. Okay, and now process 1 is under the execution, and now if the process 1 will go for the any blocked operation, so at that time again the PCB will store of the process 1 and now reload the PCB0 where the process P0 is stopped. Got it? So same thing will happen for each and every process which will come for the execution, which will go for the block state. So whenever any process come, then the process that is under the execution save this that process state and restore the another newly arrived process state for the execution. So every time PCB will be updated, whether process come for the execution, whether process go for the block state. So this is all about the context switching. Now our next topic is a thread. So what is thread? First of all, when any process is under the execution, it can create the multiple threads for the different tasks. For example, here Word is there, Microsoft Word is there. Okay, so when you will start the Microsoft Word, it will create one process. But whatever the another functionality is there in the Word, that will create the different thread for completing this task. For example, for saving the document, there is another thread. For auto saving the document, there is another thread. For spell check, there is another thread. Okay, so here you can see these are the threads. Here you can see here I have written the wrong spelling, that is of college, circuit and ICT. I have just written in a different way. Okay, so here you can see it shows the red line under that particular word. So if you will add it to dictionary, then it will not show you any error. But if you have not add it in dictionary, then it will show you the error. So that is what, that is the thread. And when the program is in the auto saving mode, at that time also the another thread is used. So this is the example of thread. So where thread is used, let's discuss about it in detail. So first of all, thread is what? Thread is a lightweight process created by a process. So processes are used to execute the large heavyweight jobs such as working in the Word. So while thread are used to carry out the smaller or lightweight jobs such as auto saving, word document or spell check, etc. So these are the different thread for one process. So when you will close the word, so that means you are closing the entire process, you are terminating the process. So all the thread will be terminated automatically. Got it? So here you can see this is the one process. In that process, numbers of threads are there. Now, thread is again a lightweight process created by the process. Thread is a single sequence stream within the process. Okay. Thread has its own program counter, its own system register and its own stack. So program counter that keeps the track of the which instructions to be executed next, and system register which hold its current working variables. Okay, and stack which contains the execution history. So like the process, thread has its own thread control block. So summary of today's lecture, we have learned about the process control block, then we have discussed about the context switching, and then we have learned the basic idea about the thread. Okay, so process control block that will keep track of the entire process, and then we have seen the context switching when process 1 will move to the block state, another process 2 will come for the execution. So what will happen at that time? So that will be done using the context switching. So context switching is used to store the information about the process states. And last we have discussed about the thread. In detail about the thread we will discuss in the next upcoming lecture. Thank you for watching. We will meet in the next lecture. Thank you.